So dust layer, again, as we talked about, as we discussed, our facilities, we always have dust and dust keeps on building, right? So if it exceeds a limit, then it can easily ignite and can have minor explosion in the place where it's, concentrated. That minor explosion like throws out the dust around in airspace and also disturbs other dust which are, that have accumulated in walls, other places, etc. That will, add to the dust dispersion, and it disperses into a larger cloud that leads to a larger magnitude explosion.
Welcome to the Feed Science Podcast Show. On behalf of Genetics, thanks for joining us and watching on YouTube. Listen on your favorite podcast app. As always, like, subscribe, all that good stuff. Let us know what you guys, as the audience, are interested in hearing about, and what kind of things are of interest to you in this particular space. Coming to you from North Carolina State University, as always, in the Prestige Department of Poultry Science and the Animal Food Manufacturing Program here. My name is Adam Fahrenholz, and my guest today is coming to us from Purdue University. This is Dr. Kingsley Ambrose. Kingsley is a professor of ag and biological engineering there at Purdue. Known Kingsley for a while. We were just catching up before we hit the recording button that it's been a while, but we've our paths intersected a decade or so ago. So it's good to see you again, Kingsley.
Great, thank you, Adam. Thanks for inviting me, and it's feeling very happy that you're doing this, very important podcast show. So
absolutely. So I'm going to ask you to just give a brief introduction of yourself and let everybody know that what we're going to talk about today is grain dust explosions. And the reason we've got Kingsley on is because that's one of his areas of expertise, and coming at it from an engineering perspective. So if you wouldn't mind, Kingsley, give everybody a bit of a history of your background and then the kind of things you work on there at Purdue.
So I'm not going to repeat what you said. So my expertise is in particle technology. So I work on anything powders, particles, ranging from grains, food, feed, pharmaceutical powders, etc. And as you said, one of my major research and focus is on dust explosion prevention, especially grain dust. So we have been working on dust explosion, like finding ways to, prevent some explosions from occurring either by research, teaching, education, etc. That's one part of my work. And, in addition to dust explosion, I do work on, other grain quality, related issues and challenges.
Genetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Gotcha. Very, very good. So obviously, grain dust explosions have been something that have been around since we first started milling grain, hundreds of years ago. And as we've gotten more mechanized, that's led to more opportunity for there to be things that cause sparks and cause hot spots and all this other kind of stuff. And facilities have gotten larger. If I recall my stats correctly, kind of mid 80s to early 90s, the rates were pretty high. And since then, we've done much better as an industry of not having as many issues with it. A lot of that has had to do with training, and there probably aren't anymore, but there might be a few people around that still remember some of the things that came out of Kansas State in the late 80s, early 90s, the deadly dust videos. I've still got a couple old VHS copies around somewhere. But with all that having been said, it still seems like at least once or twice a year, there's one somewhere in the United States. And so I guess the place to start is, why does grain dust explode? And why are grain facilities specifically so susceptible to this problem?
It's, again, very good point. So I'll just give, you provided very good, excellent background. yes, people started noticing dust explosions little over 100 years ago. Again, it came from Europe, and we in the US we were having lots of explosions. And mid 80s, early 80s, OSHA's regulation came into place. Then we started a little bit, controlling or reducing the number of, explosion, and also, reducing number of injuries and fatalities or death is also a very important point, right? So again, as you had said, we mill and we process products, right? So we handle large volumes of grain, right? So again, when we handle grains, we don't just, handle grains, right? So we bring in lots of dust along with them, and again, dust are very small particles, fine particles that comes along with the grain that we handle, we process, etc. While handling, again, yeah, we will have lots of dust, but in addition, when we process, for example, as you rightly said, when we mill, we generate dust particles, right? So it's adding to the complex issue of, finer particles within the facility. And, OSHA regulations say anything below 500 microns can explode, can lead to an explosion. So, but when we process and when we handle, those are the particles that we, generate a lot that, keeps on suspending in air and also keeps on, settling in our floor and walls, etc. That poses this challenge. Again, this dust, again, is a very fine, very dry, easy to ignite. And when they burn, again, they're not like single dust particles. As I say in my training programs, it's billions and billions of particles. So when they burn at once, you can imagine the amount of energy they release, and that leads to an, explosion. So
You're right, and we all we always talk about the triangle, right? The oxygen and the dust and the ignition source, and I think one of the things that is always interesting, and again going back to some of the stuff I remember when I was in school at Kansas State, and we during short courses we do the demonstrations and have the little plexiglass box, and it's always amazing to people that you take a couple grams of flour, and if you tried to hold a match or a lighter to it, you'll never get it to burn. I mean, it'll burn, it'll turn brown, but it's never going to catch on fire. But you disperse it into the air in an amount that just barely you can almost tell it's in the air, and then you can make the box blow up, right? And I think that's always really interesting. I did mention we've done better, but I'm sure you know the numbers way better than I do. How often do we see dust explosions occurring in grain facilities?
On an average, we see about 10 explosions happening in the US.
Okay.
Doing better, but we can still do a lot better. So, anywhere, it ranges from 7 to 12, 7 to some years are like bad, but some years are good. So you don't see many explosions from occurring. Yeah.
I'm sure that there's a number of, and I know that there are a number of different causes. So I guess my next question would be, what are the different causes that you can talk to the audience about that exist for grain dust explosions, and then what of those are the ones that are the most common that we see?
Again, I'll bring back to your point of this explosion pentagon, right? So 5 factors. If all the 5 factors are there will be an explosion, right? But we usually, we cannot contain or avoid the presence of dust, right? So we bring in lots of dust, we generate lots of dust. Dust is always there, omnipresent in our facilities. So that we cannot avoid. So one of the easiest, thing or, the convenient, factor that we can avoid is the ignition, presence of ignition. So if we can prevent any ignition source, we can prevent almost all of the, or any of the explosions from occurring. Multiple ways we can do, still, I'm not saying the other factors are not important, but the easiest one to avoid will be, preventing an ignition source. So as you have, cleanly explained, there usually is, the explosion doesn't start and end in one. So there will be a primary explosion and there could be multiple secondary explosions. So that's what we wanted to avoid, the primary explosions or the initial heating and initial, kind of burning. That if we can avoid that, subsequently, hopefully we can avoid the rest of, explosions.
So I want to go back because I've just realized that I made a mistake. And so I said like triangle because I'm thinking, fuel, ignition, oxygen, but you mentioned the Pentagon. So what of that, when we think about the dust explosion and we do think about the Pentagon, what are the 5 things that we think about? Because I wasn't including the other couple that are important. I was being very simplified, and I just realized I did that.
For, inflammable, liquids,
Right.
we use that triangle, right? So for dust, we need a couple more factors. One is, you pointed to that, like the, dispersed dust. That's another, the 4th factor. And the 5th one is like confined space. For inflammables, you don't need a confined space to explode, but for dust in general, needs a confined space for the explosion from occurring. And then the other regular, oxygen, fuel, all those things are still there.
And I remember being told, and I still think about this a lot today when I'm in facilities and going through facilities in the industry, if I'm out consulting or doing any of those kind of things, or in our own facility here at NC State. I always remember being told kind of this idea that, if you can look across the room in the facility and you don't have a clear picture of, 20 to 30 feet away because there's that much dust in the air, that's enough. Like, it's not as much as you think. That's enough to start being a little worried about what could happen.
So that's a good point. So, you don't have to go up to 20 to 30 feet. So in general, what based on the, OSHA's recommended, dust limit or, minimum explosive concentration, if you can easily see the, quantity of dust by extending your arm. And if you cannot distinguish your tip of your finger, and again, OSHA doesn't use this, since this is kind of based on perception rather than any standard, right? I know in the old, 80s, 90s, people tend, use this, like if you cannot see a 100-watt bulb in about like 3 feet distance clearly, you might be still seeing the light, but if you cannot distinguish the light clearly, then there's too much dust for an explosion to, happen.
Right. Okay. Yeah, there is a point, where, as you said, it's oversaturation, not enough oxygen and all that. So there is a kind of a sweet spot there in the middle, but obviously we see these things happening. So are we still generally seeing, especially in things like grain elevators and whatnot, is it still generally poor bearing maintenance and hot bearings, things like that? Or is it, electrical, static electricity versus, shorts in bulbs or outlets, non-explosion proof fixtures? All those things still a concern, or are there some primary things that today it's almost always feels like it's this one thing that causes an explosion?
Exactly. So all these are still a concern. We list them as the potential, ignition sources. Unfortunately, and you may know very well, you will not be, we will not be able to find out from where the ignition started if there is an explosion, right? It blows up everything. We will not be able to go back and find it. But there have been many cases, mostly from, hot works, welding, hot work, anything within the facility. Hard surfaces like hot bearing or, friction issues, those are very common. But again, the challenge is, challenges, like a couple of them, one will not be able to find out how it happened if an explosion occurs. Second is, again, in our facilities, you will know very well, when we start the operation, it's mostly 24/7. There is no break. Most often there is no break or no resting period. So that's why, most of these incidents happen from the hard surfaces.
Very good. Again, my guest today is Dr. Kingsley Ambrose. Kingsley is a professor of ag and biological engineering at Purdue University. You mentioned earlier, and I think another thing I would like to touch on again as well, is you mentioned that many of these explosions are these two-step explosions. There's something small that happens, a relatively small explosion somewhere, and then quite often there's a much larger secondary explosion. And can you talk a little bit about why those things occur, and then how much things like housekeeping play a role in that, and dust that was otherwise maybe not suspended in the air becoming suspended in the air?
This again, there's always an excellent discussion point. So many times that's why we, tend to little lag on housekeeping. So, if you look into OSHA regulations or NFPA standards, NFPA again is, National Fire Protection Association standards. They talk about two things. One is the minimum explosive concentration, and the second is minimum dust, layer thickness. So dust layer, again, as we talked about, as we discussed, our facilities, we always have dust, and dust keeps on building, right? So if it exceeds a limit, then it can easily ignite and can have minor explosion in the place where it's, concentrated. That minor explosion throws out the dust around in airspace, and also disturbs other dust which are, that have accumulated in walls, other places, etc. That will, add to the dust dispersion, and, it disperses into a larger cloud. That leads to a larger magnitude explosion. So housekeeping is very important. So when I do these training programs, I always say, when you see dust, clean it up immediately. Do not postpone. Your cleaning. Housekeeping is the most important thing. Can prevent ignition sources, but again, the fuel is the common thing, right? The fuel is the, basic thing. So if you can prevent the fuel from, creating any challenges, then that's the basic step. Again, we can go back to the triangle or the pentagon. If you remove fuel, there is no explosion, right? So, and our facilities, dust is the fuel, right? So
Dust is the fuel. Yeah. So housekeeping is a good way to help prevent explosions from occurring. We know that maintenance, and preventive maintenance especially, is really important. Following certain regulations and rules on electrical requirements, that's something else I want to get into just a little bit here in a second. But with all of those things in mind, and it's going to probably tie into that question that I'll get to at the end, but with all those things in mind, then how important does training become, especially when we know we've got a fair amount of turnover in our industry, and that this is a really potentially dangerous sort of thing? How not everybody can be an expert on what the OSHA regulations say, or where something needs to be an explosion proof, or whether this is a particular area of the facility where dust can only be at 1/8 of an inch, but over in that part of the facility, it can be more. It's hard for anybody to be an expert on that, much less our kind of line level, operator level employees or our sanitation staff. So where does training come in to all of this to try to keep everybody safe?
that's again, excellent question. So training is very important. So you touched upon multiple things, right? So it could be advanced options for preventing dust explosions, or the simplest things. I can talk from my example. I was doing long time ago. I was doing a training program in Midwest, and then there was one participant who was working in grain industry for more than 20 years. He didn't know that dust explodes.
Yeah, right.
So that's one major challenge. So if you do not, educate the workers who are on the ground, on the floor, who doesn't realize how, how dangerous it could be if you do not, again, follow the, housekeeping or minimum maintenance, preventive maintenance, etc., then what could go wrong? So starting from the ground level worker till the management is very important. So ground level workers, they should know dust explodes, what the housekeeping options are, how to keep the place clean so that there is no dust. And then to upper level management, what kind of protection options we can have, explosion proof panels or, cannons, whatever, with their budget, what's the best way can prevent, the facility from blowing up.
Yeah, absolutely.
The other important group is the, again, usually tell this in my trainings too. The other important group is the contract workers.
Oh, sure. Yeah.
That that again, many times I've seen from the past incidents. Again, we talked about hard work, right? Welding and hard work. Mostly we depend on rely on contractual workers. So they do not know that dust explodes. So they will start welding or doing hot work in a dusty area, and that leads to an explosion. So we'll have to train them too if they are going to do something. So
Yeah, that's a great point. And I think in addition to that, right, not training them so that they know the hazard is important, because one of the things that can happen in that contract situation, if they don't know that that's a hazard, and or if you have not trained them on your policies in your company for things like hot work, they may be coming in to do something that you contracted them to do that you didn't think, and in fact they didn't think at the beginning would require any hot work, and there's no need to cut. They were going to go and work on this particular piece of equipment, and then as it turned out, you know what, in order to get this out, we're going to have to go get an angle grinder and cut a hole here in the side of this bin in order to get in there. We hadn't really put that in our scope of work, but that's okay, we'll just go ahead and do it. And you didn't expect them to be doing hot work. They didn't know they were supposed to get a hot work permit, and they don't know it's going to explode. Now you've got a real problem, right?
problem, yes, exactly. So that's a great example. That many times that's what happens.
Yeah, interesting. So the last thing I want to ask you about, since this is a space that you spend a lot of time working in, and have obviously done a lot of training on and things like that, is, as I mentioned before, it's really difficult to keep track of between the OSHA regulations, NFPA, which has just recently changed from being one thing and now taking some of those numbers and putting them into a larger standard. And we hear about whether OSHA is going to adopt that or not. And we start hearing about things like dust hazard analysis now. And then, of course, there's all the regulations in like the National Electrical Code, and try to figure out what part of a grain facility or a feed mill is Class 2 Div 2 versus Class 2 Div 1. And I've been doing this a long time, and I've asked people that build feed mills and that work it. Is this a Class 2 Div 2 or a Class 2 Div 1 space? And nobody knows the answer in certain areas, because it's all. But nobody wants to have to go pull the Code of Federal Regulations or read through the hundreds of pages of NFPA or NEC. In your experience, where are the good places to go to get good practical resources on what are the housekeeping requirements, what will keep us safe, what are the electrical requirements, the NFP requirements that are centralized and even better put into language that everyone can understand? What are some good resources for things like that?
That's a very good point. So you touched upon all the three, major players, right? So OSHA regulations, NFPA standards, and NEC codes, right? National Electric Code. So, I would say to start from the OSHA regulations. Again, that gives a good preliminary basic understanding on dust explosions and, how can we avoid some of the explosions from occurring. NFPA, again, if you wanted to go in depth, if you wanted to a little bit, for example, if you wanted to design an explosion panel, definitely you should follow or go through the NFPA, standards. That will give a good guidance on how can we design a good, panel. If you are, looking for some electric jobs, new connections, then obviously, NEC codes that you should follow upon. One of the you talked about static, briefly touched upon static electricity, right? So most of the time that's very important, right? We don't ground the equipment appropriately. That will be a too high ask for a worker to know what my electric, ground wire should be, or what thickness should be, or how, it should ground to the earth or whatever. But at least, maybe the safety manager or the person whom we invite, the contractor, should know all these things. So a worker doesn't have to know all these things, but, the important thing is, when we invite people or when we bring in people to work on some of these things, we should make sure that they know these codes and regulations and standards. That's, that we have to make sure. And again, for a person working in a grain mill or a grain, handling facility, it will be challenged to keep tab, as you correctly said, keep tab of, what changes are happening around, these standards and regulations. I always tell during my training, don't rely on, duct tapes and plastic sheets. So make sure you appropriate, you know, get the right people to work on the right things.
Absolutely. And then I believe, if I recall correctly, I think you guys have at Purdue, you have a couple websites that are devoted to this that talk about the sources and the history of explosions, link out to some of the OSHA things and things like that, correct?
So we do have, again, one of my website has one of my group website has the details on, dust explosion history, incidents, and some, PowerPoint lectures or educational material that we develop through OSHA grants. And OSHA site also has some resources, including the regulations.
Okay. Yeah, excellent. I would highly encourage people, Google's your friend here. Purdue University dust explosions, and you can go find that information. Like I said, there's some good stuff out there, and some of that, because it is training related, is something helpful. That's not maybe. That has been, the important stuff has been distilled down a little bit to look at. And then obviously, and if you want to talk a little bit more as well, you guys obviously do trainings on this. And so if anybody's interested in doing that, where can they find out more about opportunities to get training on this if they think it's, particularly important for them?
Definitely one email away or one phone call away. So
very good. Awesome. I really appreciate the conversation. This stuff is it's dangerous and it's scary, but it's also really interesting. And it's something that's very, unique to things we do, us and some of the folks in sawmills and things like that. We're the ones that get to deal with this kind of a hazard. And it's something that I don't think, the public knows about. Why would they, sort of thing. And so when we bring people into our industry, it's usually something new for them to learn about. But it's obviously one of the biggest hazards we have. So I appreciate your work on it, and I appreciate you guys doing all that stuff and then sharing it with us today.
Thank you very much, Aaron. Thanks for inviting me once again. So it's great talking to you about dust explosion. So
very good, you bet. Again, my guest today has been Dr. Kingsley Ambrose. He is a professor in ag and biological engineering at Purdue University, and he works in the area of dust explosions and general particle and material handling as well. Again, this has been the Feed Science Podcast Show on behalf of Wise Genetics. Thanks for listening. I'm Adam Farentles at North Carolina State University, and we will talk to you the next time.